This is a special birthday segment. The theme today is birthday. So dilation and skull factor. I'm doing 2 lessons today because they're so related. I just want to hit them both back to back. Okay, there's really no difference. All we're talking about is really the idea of zooming. Okay, so I was just showing you the picture on my phone and moving it up and down. Did anything change with the proportions of like my arm and my leg, or did it just get bigger?
It just got bigger.
It just got bigger. Just got bigger. And that's going to be one of the key things when we dilate something. It doesn't change or morph the shape at all. It just makes it bigger or smaller. It's really pretty straightforward. So if we have a rigid motion, that's no change to the shape, right? If we have a non-rigid motion, that's a change to the shape or size. So rigid motion would be if I just pick something up, and just moved it to the other side of the graph. Just pick it up, move it. Okay. If it is a non-rigid motion, that's where the shape is actually going to move, or excuse me, get bigger or get smaller. That's all that means. The center the center of dilation is the point about all sides are stretched or compressed. So if I have, I'm going to draw real quick. Here's a coordinate, and I have this triangle. If it is the center of dilation is 0, 0, which is going to be the case for most of the problems we face, actually all of them. How would this get bigger? Would it get bigger and move over here? What do you think, Anton?
You increase the length of the sides of the triangle.
Good. Would it change the angles of it? It wouldn't. It would just make it what? Just make it bigger. So the original is always solid line. The new one, which is called the image.
Oh, I think we did.
Dash. You may have seen some of this.
Yeah.
Okay. So this, the dark one, that's the whole line. That's the original. That's the original. That's called the pre-image. And the dashed line is the image. If you forget which is which, just remember you're starting with one, you end up with one. So the pre-image is the one you start with. Okay? Pretty straightforward. All right. So what we need to do is we're going to zoom and shrink. So compress or stretch. Well, that's good. Double C. Using the scale factor. Scale factor is just called K. We don't do much tricky work with this. All we do is it's the multiple and change of size. So we just multiply our values, whatever they are, by K. So the length of the sides, if they doubled, the K would be 2. Okay. If it cut in half, it got smaller, the K would be 1/2. Gotcha. Okay, so the scale factor is equal to this fraction. The fraction of the length of the image size, remember that's the dash, that's the second one, and the length of the pre-image. Now I'm going to put my favorite way to show it's the original. Okay, talking about that OG size, the original. Okay, we're going to figure these out as we do these problems over here. So what happens, what's the effect when the scale factor is greater than 1, a decimal between 0 and 1, and when it's equal to 1? This can be pretty straightforward. What do you think happens with it getting bigger or smaller when K is equal to 1? That's the one that's maybe
Stays the
same, right? Does that make sense? If we multiply something by 1, it's the same. So if K is equal to 1, we're going to stay the same. No change in the shape. Straightforward. Yeah, I like that. More specific. No change in the size or shape of it. Okay. So now let's look at this. Dilation of a line segment is pretty straightforward. All this is talking about is stretching or compressing the length of a line segment. Okay. So if I have a rubber band over here. That one's long. All right, so we have a line segment here. If the K factor is greater than 1, what do you think is going to happen? Right? If the K factor is a decimal, what's going to happen? It's going to compress. Boing.
Okay, that was wrong.
All right, so all we have to do in this given example here, we're given that AB line segment is 6, K factor is 2. We have to find A prime, B prime segment. Okay, AB prime. See this little prime number here?
Yep.
The 1? That just means it's the next image. That's the outcome. Just the dash straight line. AB is this. A prime, B prime is going to be the stretched or compressed version, the second version. Okay. So watch how straightforward this is. We have AB. What's the length of AB segment? Segment AB? 6. Whoops. Is this really? Yeah. All right, what's my K factor for this problem? 2. What's my new length of AB? It's right there. 12. 6, that's the length of AB. The K factor, I'm scaling by positive 2. So we just get this length of 12. That's it. So this would be my B prime, and then I would label that A prime. You see, all we're doing is pretty much, maybe go all the way through. All we're doing is stretching or compressing a line. Next, we're just going to stretch or compress a shape. And it's the same deal every time. You just multiply the length of AB times K, that gets you the AB prime segment length. Okay. How do we feel about this? Thumbs up, sideways down? So far, so good? So we just discovered what? When K is greater than 1, what happens? Increases. What else can we call it? Stretch. All right, so let's do this next one, and I think we know what this is, but let's still do it. So looking here, AB is 9, K is 2/3, find AB prime. So what am I going to put in here for AB? AB line segment is 9. K is 2/3. I'm just going to put 9/1 for fun. And then we can multiply straight across, or we can cancel some things out. What do we want to do? 18/3 is 6. So in this case, look what happened. This is now my A prime, and I end up, instead of 9, it's right here at B prime. So you see what happened? It just shrunk it, right? Or what's the other word for that? When you compress. All right, you guys feel pretty confident with this?
Yeah.
All right, all we're doing is modifying the length of the line segment with our K factor. Yeah, easy. All right. Okay, I'm gonna go ahead and pause it and give you a moment to copy down the rest.
Oh, yeah.
All right. Perfect. All right. So what we're going to do is we're given our K value. We're going to have points just like here, points that are on the graph. And all we'll have to do to find our new point for our new image is to multiply the K times the X and times the Y. You see, we just end up like that. Okay. So if I was given the point, and maybe this is a triangle and this point is at 2, 3, say if my K factor is equal to 3, what would my new point be? What would my new point be? Good.
Totally.
Right?
Wait, no, would it increase by 6/3?
Yeah, that's what I said.
Good. Watch. So we're going to go 2 times 3 and 3 times 3. So our new point?
Oh, we're more.
Oh, so great.
6, 9.
Yeah.
6, 9.
How we got? Okay. All right. So that's how we find the new points. But if we're testing for a dilation, really what we're going to do here, I want you to write next to it. We're going to compare sides. And this is a really straightforward process. I'm bringing this up. All right. So which one is my pre-image up here? Dotted or solid line? Solid. Solid is my pre-image. Dashed is my new image. We'll call it the image, yeah?
Product.
Product?
Because like in chemistry, there's a reaction.
Okay.
And then it's a product.
Okay. If someone knows chemistry and math, they would know what that means.
Yeah.
For sure. Okay. So what we have to do is, let's look to see. Oh, that's why that doesn't need to be there. Get out of here. All right, what we're going to do is find our K factor. And here's the deal. Everybody pay attention right here for a moment. AB is this length, 10, right? A prime, B prime, that segment is 2.5. So since we know that the scale factor is the length of the image size, the new one, over the length of our pre-image. All we have to do is set up this ratio here, comparing those two. If my K factor is true for this side, and this side, and this side, then what are we seeing? We're seeing our key point we're looking for. Dilation is consistent between the sides. Okay, that's all we have to test. If one of them wasn't the same scale factor, then we would really be ending up with, instead of the nice dash in the middle, we'd maybe end up with this. Is that a dilation? Is that a zoom? No. It distorted it. Oh, from the big one to the small one.
Oh.
But the key is that all the sides have to be consistently grown. Right? That's not happening right here. So we know after we tested it, that's not a dilation. All right, that's what we're testing. So for this practice problem, go ahead and put dilation, question mark. That's what we're testing right now. We're doing that test. So let's make some of these ratios. Let's make some of these ratios here. What is the length of A prime, B prime?
2.5.
2.5. Okay. I'm talking about a 10. Oh, look what's going to happen. Happiness? How?
Talk amongst yourselves. The topic is East German politics of the 1980s.
All right, so the
I need a
iron
sound effect
curtain.
for that. Thank you. I agree. Jeez.
Okay, so there was like a ransom rap.
There's a what?
There's those last market.
Close enough. All right, so 2.5. What's our AB line segment length?
It is 10.
2.5 divided by 10?
It is 5 point something. Or no. Oh. Yeah.
It's 1/4, 0.25. Pretty close. All right, what is A prime, C prime line segment? 3. What's AC? 12. We reduce this down, divide both sides, top and bottom, by 3. 1/4. Okay, we're looking good so far. 1/4 scale factor, 1/4 scale factor. What does this one have to be in order for this to be a dilation? 1/4, right? It all has to be the same. That's all we're doing. All right, what is B prime, C prime? 3.75. Over? 15. You guys got it now. I see. All right, go ahead and somebody work that out.
It has to be 1/4.
2.5 divided by 10, 0.2.
2.5.
Yeah, that's.
Oh, there's like a huge glare. I didn't see the.
Oh, I
I just saw 2. I'm like.
Gotcha. Yeah, hey, that's wrong. It is 1/4,
Yeah,
right?
it's 1/4.
3.75 divided by 15. Good, 1/4. All right, so what are our scale factors? They're all 1/4. So is this a dilation? Yeah, because it all grew or shrunk at the same scale.
Oh, okay. I
See what I
you're
mean?
saying, yeah.
Okay, because this length, AB, compared to the new one, it's 1/4. It's 1/4. So we're talking about shrinking or compression or stretch? Compression or stretch? Compression.
Can we just look at it and say it's a dilation? Or do you want us to?
You have to test it. So the thing you have to accomplish is testing it.
Okay. Do you have to do every side, or can you just do 2 sides?
You have to do every side. What else?
Do you have to?
Yeah. Sound effect?
I don't really have a sound effect.
I hope they can hear that. Archery.
So comfortable.
Can we just press all of them real quick?
They only do one at a time. You have to wait. It's just, that one takes forever. That's old school.
Oh, that was like the little.
That's why you got hit with the mallet.
There's a story behind each sound.
Everyone, we can make a story. All right. We'll end with that.
That's a dog.
All right, number 123, get some Oreos. I've already bought them. They're going stale, so somebody please win.
I'll eat them.
Yes.
Shout out to you since it's your birthday.
Oh, shout out to me.
Yeah,
It's my
shout
birthday. All right.
Oh, gee.
Yep. Happy birthday on 3. 1, 2, 3.
Happy birthday,
Feeling the love. All right.